Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges and my courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, IIT-Jam, Jest and other exams related to physical science. Okay, so this is the lecture number 17. And this is the part second of differential equation. Okay, so we are solving differential equation. So this is the second part for the differential equation. And before starting the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes which are going to help you to crack the exams related to physical science. Okay, so now I'm going to start. Just let me check the voice as well. Am I audible or not? Then I'll proceed further. Okay. Haven't subscribed my channel. Yes, I'm audible. So I'm going to start. So we have studied linear differential equation of first order, right, in previous class. So there is one question which is asked in a GATE exam. Okay, I'm going to solve this first. Okay. So question 1, which is asked in GATE. Okay. So question is k1 dx upon dt plus k2 x equal to k3. Okay, and condition is given at p equal to 0, x equal to 0. Okay, and x equal to 0. The correct graph representation. The correct graph representation okay, you need to find out. Okay, and where k1, k2 and k3 are constants. Okay, are constants. So and so we have to select the correct graph representation. Okay, we have been given the option. Okay, first graph is given, this one. This is in t and this is in x. Okay, and this graph is like this. Like this. Okay, like this. And option B is this graph x, and this is in t. Okay, and this graph is like this. Okay, option C, the graph C is given. This is t and this is x. Okay, and this graph is given like this, and the graph D is given t and x. Okay, and this is like this and this. Okay, so these are the graph. We have to select the correct graph which represents this differential equation. Okay, so these are the graph which are given. Okay, so we'll solve it and find the correct graph for it. Okay, so the equation is k1 k1 dx upon dt plus k2x equal to k3. Okay, so we'll solve it. So I have already explained the how to solve first order linear differential equation in my previous class. Okay, so d upon dx is going to be plus k2 upon kx, k2 upon k1, k2 upon k1 x equal to k3 upon k1, right? Okay, so this is the equation, and this is in the form of linear differential equation, right, of first order. Okay, linear differential equation of first order. Okay, so for that we first will find if, integrating factor, right? So here px is k2 upon k1 and qx is in this equation, if we compare with the general equation, so k3 upon k1. Okay, so integrating factor is going to be e to the power integration px dx, right? And this is going to be e to the power integration k2 minus k1, k2 upon k1, k2 upon k1, k2 upon k1 dt, right? Or dx. This is dx, guys. Dt, sorry. My apologies. So this is dt, okay? And this is x. So this is dt. So we'll solve it further. So it is going to be e to the power k2 upon k1 t, right? The integration of this is constant, so it is going to be t, right? So e to the power k2 upon k1 t. Okay, so solution, I told you in my previous class, the solution is solution x into integrating factor equal to integration px, integrating factor into qx dx plus in this case it's dt. Okay, dt plus c, right? And this is qt. So these are not qx, these are pt is function of t. Okay, pt and qt. Okay, so this is t, this is pt and qt. Okay, so yeah, so now we'll put the value. So x into integrating factor, that is e to the power k2 upon k1t equal to integration e to the power k2 upon k1 t into k3 upon k1 dt plus c. Okay, dt plus c. So it is going to be x equal to, this will take first we'll solve this one. Okay, so it is going to be x e to the power k2 upon k1 t equal to, this is going to be k1 k3 into k1, and we'll integrate this, so this is going to be k2 upon k1, right? Is there any mistake we're doing? K2 upon k1. Okay, so this is the one, and e to the power k2 upon k1, k2 upon k1 plus c. Yes, here we have this. So this is k2 upon k1, right? It is integration, so it will go in denominator. So it is going to be k1 k2, right? 1 upon k2 upon k1, so k1 will go up. So k1 and k1 will get cancelled, okay, and this will go this side. So it is going to be x equal to k3 upon k2 plus c e to the power minus k2 upon k1 t. Okay, now we'll put the condition, that is x equal to, at x equal to 0, sorry, at t equal to 0 given, right? Here at t equal to 0, x equal to 0. So at t equal to 0, x is going to be 0. So we'll put it. So this is going to be, this value is going to be 0 equal to k3 upon k2 plus c, and this value e to the power 0 is going to be 1, right? So from here, value of c2 is going to be, k3 upon k1, k2, my apology, k1, k2, k2. Okay, so now we'll put the value in equation. This is, we can say this equation is minus 1, equation number 1. Okay, so this is going to be k3 upon, this is minus, guys. Okay, k3 upon k2, k3 upon k2 will take common, okay, in this equation, because c value is minus k3 upon k2, right? So this is going to be 1 minus e to the power minus k2 upon k1 t, e to the power minus k2 upon k1 t. Okay, okay, so this one, this is the value of x. Now this we have, okay, and now we'll put the condition at x equal to infinity. Okay, at x equal to at t equal to infinity, t is there, okay, at t equal to, and this is the value at t equal to infinity. So we have used a linear, this is a linear differential equation, and we solved it, right? So now we'll put the condition at t equal to infinity. When we put t equal to infinity, t tends to infinity, the value of x is going to be, this will be 0, right? E to the power minus infinity 0. So it is going to be k3 upon k2, right? It means at t equal to infinity, value of x is k3 upon k2, which are constant, right? So which is constant, okay? K3 and k2 are constant, so k3 upon k2 is constant, okay? So at t equal to infinity, value of x is going to be constant. So now we'll check the graph and select the correct option, okay? So here you can see this graph is exactly telling the same. At t equal to infinity, you can see that this is going to be infinity, right? At infinity. So at t equal to infinity, you can see that the value of x is constant, right? This value is constant. Same value here, same value here, same value here, right? So option is the correct one, because at t equal to infinity, this graph is, when at t equal to infinity, this graph is going at infinity, right? And the value of x is going to be constant. So this value, you can see it's constant, right? So graph A is the correct, yeah, it means option A is the correct option, okay? So this is the correct option, and this question is asked in GATE. Next, guys, next is equation reducible to differential linear differential equation, okay? How we will reduce that into reducible that in differential linear differential equation, okay? So I'm solving now. Meanwhile, just let me check the connection. Is it working fine? Yes, it's working fine. Well, next, that is reducible to the linear differential equation. Very important this as well. So reducible to linear differential equation. So we have given differential equation, so we have to reduce that into linear differential equation. Okay, so of this form, guys, I'm going to write this form in red pen. Okay, so this is dy over dx plus py equal to qy to the power n. If any equation is in this form, we can reduce this equation into a linear differential equation and solve it. Okay, how to do it, that I'm going to tell you now. Okay, so if you simplify this, so it is going to be 1 upon y to the power n, will go here, right, dy over dx plus is going to be, this is p upon y to the power, this is y to the power n, y upon y to the power n equal to y will go here, so y to the power n minus 1, y is going to be q. Okay, so here what we can do is we can say let 1 upon y to the power, so this is like this is this. Okay, this is y is not there, y here. Okay, 1 upon y to the power n minus 1, we will say it is z. Okay, so let 1 upon y to the power n minus 1 is z. Okay, so in that case, this is going to be minus n minus 1. Okay, minus n minus 1, will differentiate it, okay, with respect to x. So it is going to be 1 minus n minus 1 y to the power n minus 1 minus n minus 1 minus 1. Okay, minus 1 dy over dx is going to be dz. Okay, we have differentiated, so it is going to be dz. So from here what we are going to get is 1 upon, if you simplify it, okay, so if you simplify it, so this is going to be, so I'll simplify it as well. Okay, so it's going to be minus n minus 1, and this is y to the power minus n. Okay, this will minus minus plus, this will get cancelled, y to the power minus n dy over dx is going to be dz. Okay, this is dz upon dx. Okay, dz upon dx, we have differentiated with respect to x. Okay, so this is going to be, if you simplify it further, it is going to be 1 upon 1 minus n. Okay, so like we can write like this, so 1 upon y to the power n dy over dx, this value is going to be 1 upon 1 minus n dz upon dx. Okay, very important. This you need to memorize and note down, right? So if any equation is in this form, right, so we'll take 1 upon y to the power n minus 1. So this power may be anything, right, any integer, 2 3 4 5 6, right? So this is 1 upon y to the power n minus 1, we'll put as z, then we'll differentiate it, and then we are going to get this value, 1 upon y to the power n dy over dx equal to 1 upon 1 minus n dz upon dx. Okay, dz upon dx. So now in this equation, right, what we are going to do, in place of this this one, 1 upon y to the power n dy over dx. Okay, in place of this we are going to put 1 upon 1 minus n dz upon dx. Suppose y to the power 5 is there, so this value is going to be 1 upon y to the power 5 dy over dx equal to 1 upon 1 minus 5 dz upon dx. I will solve one question with example, right? Then it will be more clearer to you. Okay, so this is this equation. So now after that, the equation is going to be, like this: 1 upon 1 minus n dz upon dx, and this value is going to be pz. Okay, pz equal to q. So see, now this equation is reduced into linear differential equation, right? Very important. Okay, so so here we have reduced this differential equation of this form into this form. Okay, so and here, okay, yeah, this is the one, guys. Okay, so now I will take one example and will solve the question, then it will clear your doubt. Okay, so we're going to solve it. Okay, here one more thing you can write. Okay, no need to write, so directly we are going to solve question. Okay, question number 2 as an example. Okay, so there's a question is dy, just give me 1 minute, let me check. Yes, connection is fine. Okay, so it's dy over dx plus 2xy equal to 2x cube y square. Okay, 2x cube y square, dy over dx, 2x cube y square. Okay, so this is the question. So here you can see y to the power 2 is there, right? Here, like this, y to the power n, so n equal to 2 here, right? So we'll just put this value of n here, and we'll directly get the equation. Okay, so we can write it like this: dy over dx into 1 upon y square. Okay, plus this is going to be 2x upon y, because y will cancel y square, so it is y is going to be 2x cube, right? So this equation is going to be, now we can say, let 1 upon y to the power n, y to the power n minus 1 equal to z we want, right? So y to the power n minus 1 here is n equal to 2, right? So n minus 1 is y, right? So 1 upon y, so 1 upon y equal to z. Okay, and so this term 1 upon y square dy over dx is going to be like this, is in this form, right? Here, this is going to be, this term is going to be 1 upon n minus 1 dz upon dx. So this is going to be 1 minus n minus 1 upon n, 1 minus n. So this is 1 upon 1 minus n is 2 here. Okay, and dz upon dx, right? So this is going to be minus dz upon dx. So now we'll put the value here like this in this equation. Directly we can also put the value. So this is 1 upon, you can just memorize this and you can directly put value. Okay, this is also okay. So it's 1 upon 1 minus n, right? So this is going to be minus dz upon dx after putting value here, right? Dz plus pz, right? Plus pz is this is 1 upon y is z, right? 2xz is equal to 2x cube, right? 2x cube. So this is the equation, guys. So we have reduced this equation into linear differential equation. Okay, now we'll solve it. So these things you need to, 1 upon y equal to z, and 1 upon y square dy over dx value is minus dz upon dx. Okay, so now we'll simplify it. So this is, we can write it like, okay, so we can write it here. Dz upon dx will multiply by 1. Okay, minus 1 in both sides. So it is going to be minus 2xz equal to minus 2x cube, minus 2x cube. Okay, well, Now we'll solve it. So they now will find integrating factor, and this is going to be integrating factor is going to be e to the power integration px dx. Okay, so px dx is px dx. So px is here 2x, right? So if is going to be integration e to the power integration 2x dx, right? So this is going to be e to the power x square, right? And minus is also here, right? So minus e to the power minus x square. Okay. Well, and so solution is going to be z into integrating factor, that is e to the power minus x square. We know, I have already explained how to find solution and integrating factor in my previous class. Okay, so this is going to be integrating factor e to the power minus x square, okay, into qx is minus 2x cube dx plus c. Okay, so it is going to be now z into e to the power minus x square equal to e to the power minus x square. We can write x square, and this is going to be x square into 2x into dx plus c. Okay, so we have to integrate this. Okay, for integrating this, let minus is also here, right? This is minus. Fine. For integrating it, let we can say x square equal to t. Okay, so it means 2x is going to be dt upon dx, and so that implies dt value is going to be 2x dx. Okay, we are solving this integration first. So this is going to be e to the power this is directly we can write also. So here we can write it. So it is going to be, I'm going to write directly. Okay, so this is z e to the power minus x square. For solving, we have put that we say x square equal to t we put, right? So here we'll put the value. So integration minus x square, this is e to the power minus t, and dx 2x dx value is here, 2x dx value is this 2 dt. This is going to be dt, and x square is also here. X square means t. X square is t. We have supposed, okay, x square equal to t, right? So t dt plus c. We have just put x square equal to t to solve this integration. Okay, so this is e to the power minus x square is going to be, finally we'll put value of t. Okay, so this is, we'll use integration by parts. Okay, so this is going to be minus first function, that is t, integration of second minus t, and okay, so this is going to minus minus plus t, minus integration differentiation of first one, and integration of this minus minus plus e to the power minus t. Okay, so I'll integrate again. So it is going to be minus e to the power minus t. Okay, minus plus. Okay, because minus plus, and this is the minus. Okay, minus, then this is going to be plus. Okay, so e to the power minus t plus this plus c. Okay, now we'll put the value of x. So it is going to be, it is very simple integration, guys. I have used just integration by part. You can easily do it. So e to the power minus x square, this is plus, this is plus. Okay, so this is going to be e to the power t, we can take common, so t plus 1 e to the power minus t plus c. Okay, so so it is equal to e to the power minus x square. Now we just put value instead, in place of, will replace t by x square, because that is the actual one. X square plus 1 e to the power minus x square plus c. Okay. Okay, so now we'll put the value of z as well. Okay, because we have consider here 1 upon y equal to z, 1 upon y equal to z. Okay, so this is going to be, instead of z we'll write 1 upon y e to the power minus x square here, right? And x square plus 1 equal to x square plus 1, x square plus 1, x square plus 1, and e to the power minus x square, e to the power minus x square plus c, plus c. Okay, so this is the answer, guys, for this. Okay, so we have seen how we can reduce this type of question into linear differential equation. Okay, so just we have what we have done is this one. Okay, this is the general procedure, right? So instead of 1 upon y to the power n dy over dx is going to be 1 upon 1 minus n, that depends on power. Okay, is dz upon dx plus pz equal to 0, and 1 upon y to the power n minus 1 we have, say, that is z. Okay, so using this we have solved this question. Okay, very good question. So I would request you practice other questions, similar questions, and then your all doubts will get clear. Okay. Okay, next question we are going to, next question is question number 3rd, I believe, that is dy over dx plus 2xy equal to 2x cube y. Okay, so this is the question. Okay, there is only y, but there so we don't need to use that method. We can directly solve it by separation of variable method. How? If we can say dy over dx equal to, because it's power 1. Okay, power y to the power 1, if there is a power more than 1, then we can use this method. But if it on, or if it is only 1, y to the power 1, then we can easily solve it by separation variable method. I'll tell you how. So this is going to be 2x cube minus 2x cube minus 2x cube y. Okay, 2x cube y minus 2xy, right? And then we can take y here, so dy over y, and x we can take here 2x cube minus 2x dx, right? Integration plus constant. Just y we have taken this side, x this side. Okay, and this, now we can integrate it. So this is ln y is going to be this is 2 x to the power 4 upon 2 minus 2x square upon 2 plus c. Okay, so this is going to be 2 will get cancelled. Sorry, the x power 4, this will be 4. Okay, so this is going to be ln y equal to x to the power 4 by 2, 2 will get cancelled, and this x square plus c minus x square plus c, this one minus x square plus c. Okay, so this is the answer. Well, so these are the questions. Okay, so how to reduce the question of this form I have explained. Okay, so now we are going to study exact differential equation. Okay, so what is exact differential equation and how we are going to solve those exact differential equation. Okay, okay, so now exact differential equation. Exact differential equation. Okay, so this is question is, so okay, I'll tell you the procedure first. Okay, so suppose we have this equation md in this form, mdx plus ndy equal to 0. Okay, so we have this form, and where m and n are functions of x and y. Okay, m and n are functions of x, y, and okay. So if the equation is in this form and m and n are the function of x, y, and if del m upon del y equal to del n upon del x, del n upon del x. Okay, so del m upon del y equal to del n upon del x. If this is equal to this, right, then we can say this differential equation is exact differential equation. Exact differential equation. Okay, exact differential equation. Okay, and if it is exact differential equation, then solution of this exact differential equation is going to be integration m dx plus integration n dy, okay, equal to 0. Here is condition is this is considering y as a constant, y as constant. If it is xy function, so we'll consider y as a constant. This is very important. We'll write only those terms which are only y dependent term. Okay, so only y dependent term, so only y dependent term and we'll write, and which are x and y both dependent term, then we are not going to write that. Okay, so for n we'll write only those terms which are dependent on y. Okay, and here we'll take y as a constant. We'll write a complete n. Okay, how we are going to do is, now I'll give examples. I'll take one example. Okay, question 4. Okay, question is 5. Next page. Question is 5x to the power 4 plus 3x square y square minus 2xy cube dx. Okay, this is m, guys. Okay, which is function of xy, right? Dx plus 2x cube y minus 3x square y square minus 5y to the power 4 dy. Okay, this is y to the power 4. Okay, this is n and this is m. Okay, sorry, my apology. This is m and this is n. Okay, so now first we'll check whether this differential equation is exact or not. Okay, so how to check? This is n is a function of xy and m is function of xy. Okay, so how to check it? Del m upon del y, and we'll find out del n upon del x. Okay, so first del m upon del y. So here we'll differentiate with respect to y. So this is going to be 0. This will be y, right? So 6x square y minus 3 to the, and this is y, right? So this is going to be 6xy square. 6xy square. Okay, 6xy square. Similarly here dn upon dx is going to be this one, 6x square y, this one 3 to the 6x square with respect to x, right? 6x square y minus this one with respect to x, right? So 6xy square. So you can see this implies del m over del y equal to del m over del y equal to del n over del x, means exact. Okay, so exact differential equation. So it is exact differential equation. Now solution, very simple, that is integration m dx, right? x to the power 4 plus 3x square y square minus 2xy cube dx, plus this is considering y as a constant, okay, taking y as a constant, okay, plus integration, all we will take only those terms which is dependent on y only. We will take only those terms which are dependent on y only. This is dependent on x and y, this is x and y, so only this one we will take, minus 5 y to the power 4 dy, because this is only dependent on y, plus c equal to 0, plus c equal to 0, okay, plus c equal to 0, so we will add one constant, plus c equal to 0, okay. So now we'll simplify it, very simple. So this is going to be 5 x to the power 5 upon 5 plus this one y square, y, there is no y, right, and this is going to be 3 x square x cube upon 3 y square, while y we will take y as a constant, okay, uh, and this one is going to be 2 x square by 2 y cube minus 5 y 5 upon 5 plus c equal to 0, right. So this equation is going to be 5 will get cancelled, so this will be x to the power 5, this will get cancelled, and this will get cancelled, so x cube plus y square plus x cube y square, x cube y square, 2 is also here, no, okay. 3 is there, right, x cube, okay. Next 2 will get cancelled, so minus x square y square y cube, sorry, x square y cube, and this is 5 will get cancelled, y 5 plus c minus y 5 plus c equal to 0, okay. So this is, okay, x square y cube, and is there any mistake we have done? Let me just check. 3x square. No, we haven't done mistake. X cube x square, right? 6. Oh, no, that's correct, right? Okay. So this is the answer, guys. I hope you understood it. Okay. So this is how we solve exact differential equation, okay. So we'll check the check first that whether this equation is exact or not. If it is exact, then we will use this method and solve the exact differential equation. Okay, next point. Okay, next is, okay, very important. So this is second order differential equation, okay, very important one. Okay, so second order differential equation. So the second order differential equation form, I'll write the general form. So that is d2y over dx square, d2y over dx square plus p dy over dx plus qy equal to r. Okay, r is function of x, okay, rx. P is also function of x, q is also function of x, okay. So this form, okay. If any equation is in this form, d2y over dx square plus p dy over dx plus qy equal to r, where p q r are the function of x, okay. p q r function of x, function of x, then this equation is called linear differential equation of second order. Okay, linear differential equation, linear LDF, linear differential equation LDF, linear differential equation of second order. Okay, linear differential equation of second order. Okay, this form, very important, and you will get many questions in your examination related to linear differential equation of second order. Okay, so we are going to study, as of now we are going to study homogeneous equation. In homogeneous equation, r is 0. Okay, r equal to 0. So homogeneous linear differential equation of second order, or homogeneous linear differential equation of second order, is going to be d2y over dx square plus p dy over dx plus qy equal to 0. So this is linear differential equation of second order. Okay, homogeneous linear differential equation of second order. Okay, so this one, first we'll solve this one. Okay, in next class we'll solve linear differential equation of second order, this when it is non-homogeneous equation. Okay, so for that here we have to only find out complementary function CF, and in this equation we have to find particular integral as well. Okay, so there are procedures for finding particular integral, right, for different values of r, which is function of x, right, which we will do in next class, but here we are going to solve today. We are going to discuss a linear this is homogeneous linear differential equation of second order. Okay, so I'll directly solve by example, giving example. Okay, so I'll start with the first question. Okay, before that I think I'll write it. Okay, this is important because you should know how you find it. Okay, so linear differential equation, linear differential equation of second order, which is homogeneous. Okay, homogeneous means right hand side is 0. Okay, r equal to 0. So linear differential equation of second order. Okay, or we can say homogeneous homogeneous linear second order differential equation. Okay, a linear differential equation of second order homogeneous. Okay, so I'll write the general form for this again. So dy over dx plus d2y over dx square, okay, plus p dy over dx, okay, plus q equal to 0, qy equal to 0. Okay, so this is the general form. Okay, and how to solve it? For solving it, what we are going to do, will say let y equal to e to the power mx. Okay, so now we'll put so e to the power mx, so dy over dx is going to be m e to the power mx, right, or we can write m y. Okay, similarly d2y over dx square is going to be m square e to the power mx, that is m square y, right, and we'll put these value here in equation this. Suppose this is equation A, in this equation, so this equation is going to be after putting the value of dy dx d2y over dx square dy over dx and y, this is going to be, and e to the power mx will go in right hand side, will become 0, so it is going to be m square y plus pmy plus q plus qy equal to 0, or we can say m square plus m square plus pm plus q is going to be 0. Okay, so this is called auxiliary equation. Okay, from here we'll find complementary function. So okay, now we'll directly write this. Okay, so I'll give one example. Okay, I'll solve question, then it will be more clearer to you. Okay, question number 5. So this is like d2y, very simple, d2y over dx square minus 3 dy over dx plus 2y equal to 0. Okay, so you need to solve it. So you can see it's a linear differential equation of second order, homogeneous, right? Because the right hand side is 0, it means it's a homogeneous linear differential equation of second order, right? So directly will not write this value y equal to mx. Okay, we'll directly write the value. We can write it. So auxiliary equation is going to be m square minus 3m plus 2 equal to 0. Okay, so we'll solve it. So this is going to be m square. Okay, but before solving, I need to tell you something. Okay, I will come to this later. Here I'm going to solve something. There are conditions. Okay, very important. I'm making a chart, so note down. Okay, so this is auxiliary equation. Okay, auxiliary equation. So now there would be different types of root, guys. So suppose there are real root m1 m2 real and m1 not equal to m2. Okay, if that is the case, in that case complementary function, okay, CF is going to be c1 e to the power m1x plus c2 e to the power minus sorry, my apology, this is e to the power m2y m2x. Okay, m2x. Okay, second case is if m1 and m2 are real, are equal and real. Okay, so in that case the CF is going to be c1 plus c2x e to the power mx. Okay, next point is if m1 and m2 are complex number. Okay, complex number. So in that case CF is going to be c1 e to the power m1x plus c2 e to the power m2x. Okay, or you can say, yeah, this one. Next is m1 m2 are m1 and m2 are rational number, we can say. So m1 and m2 are complex conjugate. Okay, complex conjugate. m1 and m2 are complex conjugate. Leave this in this. Okay, I will discuss later. Only this one is good. If you get question, then I will explain it. Next, okay, just give me yeah, this we can say here. M1 and m2 are complex conjugate. Okay, complex conjugate. In that case CF is going to be complex conjugate of the form like this, alpha plus minus I beta. Okay, so how we are going to write this solution? This we are going to write CF equal to C1 e to the power alpha x e to the power alpha x e to the power alpha x into C1 cos beta x plus C2 sin beta x. Okay, this is going to be complementary function. Okay, so these are the points. Okay, so if a real number real and not equal to and both are m1 and m2 are not equal, then this will be the complementary function, this will be the solution. If both are equal, this will be the solution. And if both are complex conjugate, okay, complex conjugate number in this form, alpha plus minus I beta, then CF is going to be e to the power alpha x C1 beta cos beta x plus C2 sin beta x. Okay, so now I will solve with example. So the question is d2y over dx square d2y over dx square minus 3 dy over dx plus 2y equal to 0. Okay, so this this is homogeneous linear differential equation of second order. So directly we can write auxiliary equation. This is going to be m square minus 3m plus 2 equal to 0, right? M square minus 3m plus 2 equal to 0. So these values are going to be m square minus 2m minus m plus 2 equal to 0. So this is going to be m common, m minus 2 minus 1 common, m minus 2 equal to 0. So m value of m are going to be 1 and 2. So these are real numbers and not equal to 0, right? And both are not equal, right? So complementary function, that the solution of this equation is going to be CF is going to be, right, that we know. This is C1 e to the power x plus C2 e to the power 2x. This one C1 e to the power m1x plus C2 e to the power m2x. Okay, so this is the answer. Okay, yeah, the same question. Okay, next question, question number 6. This is also a good question. This is d2y upon dx cube minus 8y equal to 0. Okay, so you need to solve this. So this is also simple. So we'll write auxiliary equation, and this is going to be m cube minus 8 equal to 0, or we can write m cube minus 2 cube equal to 0. We'll use a cube minus b cube formula. So this is going to be m minus 2 into m square plus 2m plus 4 equal to 0. Okay, so m minus 2 will solve it by Sridharacharya formula, right? So this is going to be minus 2 plus minus b square minus 4ac, that is 4 into 16 upon 2, right? That is m equal to m equal to 2 comma this, right? And we solve it, so value of m are going to be 2 comma 1 plus minus iota root 3. Okay, these are the values of this. Okay, simplify it. So this is going to be 12, 12 minus 12. Okay, so this is going to 2 root iota 2 root 3. 2 will get cancelled. So this is going to be 1 plus iota root 3. Okay, so now we can write complementary function, right? So this is going to be CF is going to be, solution is going to be C1 e to the power 2x for this root. Okay, for this is going to be, which I told you, for complex conjugate, because these are complex conjugate, right? So this is going to be e to the power alpha e to the power x C1 e to the power C1 cos beta x, right? So this is C1 cos root 3x plus C2 sin root 3x. Okay, this one we have used, this one e to the power minus alpha x equal to C1 cos beta x plus C2 sin beta x. Okay, so this alpha is there. So here alpha is alpha value is 1 and beta value is this, right? Root 3. So this is e to the power x C1 cos root 3x plus C2 sin root 3x. Very simple. Okay, but very important, guys. Okay, next question we're going to solve. Let me just check time. Okay, Okay, so this question is question number third. We'll quickly do it. Question number 6 or 7. Okay, so this question is going to be, I don't remember the question. Okay, so the question, this is a very good question. So this is d2 y over dx square plus 2 dx upon dt plus x equal to 0. Okay, you need to solve it, and conditions are given at x equal to 0, sorry, at t equal to 0. This is t square. Okay, so at t equal to 0, at t equal to 0, x equal to 1, and at t equal to 1, uh, again at t equal to 0, dx upon dt equal to 0, and we have to find at t equal to 1, we have to find value of x. Okay, these two conditions are given. Okay, t equal to 0, dx upon dt equal to 0, t equal to 0, x equal to 0. So first we will find auxiliary equation. Similarly, it is simple, m square plus 2m plus 1 equal to 0. So this is going to be m plus 1 whole square, right, equal to 0. So m value, m plus 1, m plus 1, m plus 1, m plus 1 equal to 0. So value of m are minus 1 comma minus 1, right? So what would be the solution for this? So this is going to be this one. So the complementary solution, that is going to be, which one we have already write as c1 plus c2 c2t e to the power minus t. Okay, this would be the solution, right? So now there are different conditions which are given. So now we have the function cf, that is x equal to, right, x equal to, this is the x, cf means the solution, x equal to is going to be x equal to c1 plus c2t e to the power minus t, right? Now we'll put first condition at x equal to 0 and t equal to 0. At x equal to 0, t equal to 0, so 0 we'll put, this is c1, this is 0, c1 plus 0 e to the power 0, right? So this means value of c1 is very simple, value of c1 is 1. Okay, now this equation is going to be x equal to 1 plus c2t e to the power minus t. Now we find dx upon dt, okay, dx upon dt, and this is going to be these are two functions, right? If we will use this product of differentiation, and that value is going to be e to the power, I'm directly writing, so it's very simple differentiation. So e to the power first function, this is second function. Okay, so e to the power t into minus 1 minus c2t plus c2. Okay, this is equation 2. Now we'll put the second condition at t equal to 0, at t equal to 0, dx upon dt is going to be 0, right? If you put this in equation 2, so this is going to be 0 equal to e to the power 0 minus 1 plus 0 plus c2. Okay, so implies value of c2 is going to be 1. Okay, so now c1 c2 value we have find. Now value of x is 1 plus t, c1 c2 is t, and e to the power minus t. c1 c2 value we have put. Okay, so this is the answer. Okay guys, well, okay, Okay guys, so before ending the class, I would request everyone who haven't subscribed my channel yet, please subscribe my channel and watch my uh, free live classes, okay, and which are going to help you to crack the exams related to physical science. Okay, okay guys, thank you so much for watching. Bye now.